Hello and welcome. We are here today for a fireside chat with Vijay Sakaran, Johnson Controls Chief Technology Officer, and Sastry Malati, FogHorn's co-founder and CTO, to talk about JCI's recent acquisition of FogHorn. Listen, we're thrilled to be here to chat with Vijay and Sastry on a truly transformative acquisition. We hear from our Johnson Controls customers worldwide, as well as the global market itself, how edge technology, AI, intelligence is a key element to the future of commercial buildings and real estate value. So let's get into it. With that, Vijay, why is the FogHorn acquisition so significant for JCI and our customers?
Thanks, Mike. That's a great question. And we're extremely excited about the FogHorn acquisition because it really aligns to our strategy of driving this fully smart autonomous building and intelligence, across all areas of the smart building ecosystem. As you know, as we think about the smart buildings ecosystem, the edge is a really critical part of that ecosystem, where all the devices connect into from the building, where all of the data is ingested and then flowed up into the cloud, where we're able to really do some machine learning and processing and create valuable outcomes, as we go forward for our customers. What the FogHorn acquisition allows us to do is really take a lot of that intelligence that's now being performed at the cloud and bring it to the edge, which is where we believe that there's going to be a really game-changing view of the value of the edge in the smart buildings ecosystem going forward. Because if you think about it, as equipment types have alerts and failures, and you want to do rapid optimization of devices at the edge, without taking that data all the way up to the cloud and back, edge AI is what's going to separate the companies that can respond more quickly and buildings that can be more autonomous, than those that don't have that capability. And that's exactly the capability that FogHorn brings to Johnson Controls. FogHorn is the leader in edge AI, and by acquiring FogHorn and integrating that as part of our OpenBlue Bridge edge platform, we are truly taking the next step in terms of enabling the intelligent, fully smart autonomous building.
Let me introduce Sastry in a new role as Vice President and Head of AI, reporting directly to Vijay. Sastry, can you tell us a little bit more about FogHorn and who FogHorn is and what the problem is that its technology solves?
Thank you, Mike. Thank you, Mike and Vijay, for the warm welcome. So FogHorn, we're a Silicon Valley-based edge AI company. And I know these all sound like little buzzwords here. What we wanted to solve was, especially in the industrial and commercial context, whether it's buildings, manufacturing, oil and gas, traditionally, all of the assets and the equipment that when there are failures or anomalous conditions in those equipment, their traditional way of sending all of that information into a cloud where the data gets processed and then the results get sent back into the edge, that meets with lots of challenges in that process, starting with limited to no connectivity, cybersecurity potential, cybersecurity attacks, things of that nature. But most importantly, when there are failures, especially anomalous conditions, potential failures occurring, people would want to know ahead of time, before they happen, not after the fact. So what we set out to solve the problem was, how do we connect directly to the data sources coming in from these assets, whether they are sensors, traditional digital sensors, audio, video, vibration, acoustic, what have you, combine them all together, use this technology, what we refer to as sensor fusion, bring them together, do the machine learning analytics live at the source itself. Now, some of you might be thinking, what's really new in this machine learning analytics? It's been around for quite some time. That in itself is not a new subject or technology. What's really new that we innovated on is, how do you do that in a constrained compute environment? You don't have a lot of compute power at the source at the edge, especially when you talk about a building automation system, when you talk about a manufacturing machine, an oil rig. So being able to do this kind of deep learning, machine learning at the edge on live source streaming data and be able to alert the operators to exactly what's going on ahead of time before things happen. That's really what we set out there. We've had early success, doing a lot of these partnerships and with industrial companies, the likes of, the GE, the Bosch, and Honeywells of the world. And then we started building a lot of the what we call the out-of-the-box solution. And the last few years, we've also ventured into optimizing the building automation systems, reducing the energy savings, and we built a number of those solutions and deployed across a few customers. This is directly in line with Johnson Controls' vision for decarbonization, sustainability, smart and autonomous building. So this matter has made perfect sense for us, and we actually see this as a perfect opportunity for us to take our technology combined with the firepower of Johnson Controls, obviously the go-to-market presence, the customer base, the innovative OpenBlue platform, and combining these two absolutely brings scale. And I'd like to say a lot of people like to call 1 + 1 = 3. I like to call it 1 + 1 = 11. That's how I like to see it. We want to get to that scale. I'm super excited to be part of this journey.
So a wonderful explanation of the value opportunity. Let's back up for a second. We've talked a lot about edge AI, smart edge, if you will, today. And let's step back and understand and explain a little bit what we mean by edge AI and why it's so important and beneficial to customers. Why does it matter where compute and intelligence resides? Maybe VJ, you can start us off.
Thanks, Mike. That was a critical factor in terms of our decision to pursue and ultimately acquire FogHorn, is the value that edge AI brings as part of really enhancing that smart autonomous building value proposition. So number one, as Shastri mentioned, is the reactivity. So when equipment types or alarms or signals happen in a building context, they're happening in real time. And so to take all of that data, move it up to a cloud, apply machine learning and analytics and AI on top of it, and make that round trip with those insights that can detect a problem and resolve it, depending upon how it's architected, that could take, hours, days, months, and that's not very real time. That's not very autonomous to actually be able to perform the correction. So number one, the real time nature of the way that buildings operate and faults need to be detected is really very much aligned with the value that edge AI brings to the table. Number two is the data. As we all know, the world is exploding in data. There's being more and more data being captured from sensors and different kinds of equipment types and spatial movements and alerts that are generated by those equipment types. And if you're going to put all of that data on the cloud now to perform analytics, ML, and AI on it, that's a lot of data that's going to be collecting up in the cloud over time. And that's going to really drive up both processing costs, just in terms of the algorithms that are required to run on those data sets, as well as cloud consumption costs that are going to be challenging for some smaller customers to bear over time, and so for all customers for that matter. And so our goal is to fully enable that smart autonomous building for all types of facilities, whether those are retail stores, warehouses, pharmacies, all the way up to complex campus enterprises. And we believe that by doing more at the edge, we're really making that much more accessible and affordable to really drive that smart autonomous building vision across all different types of industries. The other piece is that there's a lot of intelligence that can happen at the edge that can really make things much easier in terms of organizing the topology and the taxonomy of a building landscape. And so you can think about what we fondly call the digital twin. And for us, the digital twin is really an informational and visual representation of the space as the space continues to get evolved. Right now, the way that digital twins work is that we collect a lot of information at the edge, we bring them to the cloud, we organize it, and there's a fair amount of processing that happens. imagine a world where you do a lot of that tagging and standardization right at the edge and that reconciliation, streamlining the data processing that needs to happen up in the cloud to really represent that building structure. So, what we see as a major trend is that as more and more happens at the edge, it'll actually allows us to accelerate, the deployment of that fully smart autonomous building. And we believe that the edge is a critical capability that companies will need to deploy as their spaces become more and more complex over time.
So let me pose the same question to you, Sastry.
Thank you, Mike. So Vijay explained this very clearly in exactly the value proposition, the edge AI. I'd like to add a little bit more color to it, especially when it comes to machine learning. I know a lot of the times people think that it's a one-time thing. Data is a big deal for a lot of these large customers. They do not want to have this data leave their premises. Right now, when you train the machine learning models to work on this data, both good and bad, and deploy these models to infer these predictions, that's all great. But what happens over time typically is that things do change. Calibration of these sensors, environment, the equipment, behavior, things might change, which is leading to potentially degradation in the level of accuracy in how we're predicting all of these things. So this is where the edge AI also comes into play in one of two ways. One is this what we call the closed loop machine learning. How do you detect this level of degradation in the accuracy of these predictions and be able to incrementally update and retrain these models, especially when there's large volumes of data involved? And then secondly, how do you periodically retrain it? So in order to maintain the continuous level of accuracy. And a lot of these technologies today, people start using these terms like reinforcement learning and things like that. All of those capabilities and technologies are built into this edge AI, which takes the human out of the loop and take into account any adjustments and changes that are occurring in the building automation systems or the equipment that the customers are working with. This is where the power of edge AI comes into play.
Great, thank you very much, Sastry. Let's talk a little bit more about real life examples, specifically to building customers, real estate, customers. So maybe could you provide an example of real world use cases which demonstrates why edge AI is so important for building customers themselves? Think maybe, not only the impact on buildings value and strategic outcomes affected, such as energy use, sustainability, that kind of thing. Why don't we go to Sastry again first?
That's a great question, Mike. So I'll give you a simple example in the building automation system. We have deployed this solution in one of the largest school districts here in Florida in the United States. So the challenge was simple as this. Many a times these building owners, in this case happens to be a K-12 school district, they would come back and say, look, my utility bills are too high. Or there is a convenience factor. For example, if somebody wants to schedule an auditorium for a game, like a basketball game, or if somebody wants to schedule, an SAT test classroom off hours and things like that, or if the equipment is not functioning, it's not the HVAC system, the air handling unit, the chillers are not working well. So all they are left with today, prior to having a solution like ours, would be to go dispatch a technician potentially ahead of time. After the fact, is going to disrupt their schedules and so on. So this edge AI, the way we deployed this for them, we deployed this edge gateway that runs on one gateway per campus, and it actually connects to the building automation systems such as Metasys, Johnson Controls Metasys, takes into account all of the signals from, like thermostats, energy meters, and things like that. And also takes into account the user information input as to what do they want to do, what is their schedule, things of that nature, combines them all together, and then more. For example, if let's say the class starts at 8 o'clock and the teachers and students are going to come in at 8 o'clock. Typically what happens is if you want the room to be at certain temperature by 8 o'clock, you put the building automation system in a standby mode, say fixed pre-timed 2 hours ahead of time. But in reality, you may not need that. Maybe the temperature outside is already very close to where it's supposed to be, or maybe the equipment actually takes a lot less to bring down the temperature to a certain set point. So taking all of these into account, applying machine learning to identify when should we actually start the building automation system, when should we start the air handling unit, and what should be the set point temperature in order for us to reach the desired temperature. All this is done locally there and then directly written back onto the system. No technician is involved, no human being is involved, just the desired inputs are provided through a simple web-based interface. And that information is combined with the live data coming in from this building automation system to automate to a closed loop control. Closed loop control is the key word here, is the operative word here. Without a human being involved, how do you automatically write as well as adjust it? Here is the other thing too. Sometimes, without intentionally or unintentionally, people actually go and modify and change things in the building automation system, which creates problems too. So the edge AI is actually able to detect such level of discrepancies in the building automation system and be able to override it back to what it is supposed to be and things like that. So the combination of giving the convenience to the staff, whether it's teachers, principals, or whoever needs to control this, as well as applying AI to control the building automation system to optimize the energy consumptions. And the third aspect is proactively detecting potential equipment anomalies and failures. Let's say if for whatever reason the air handling unit is taking forever to bring down the temperature to the dead temperature, how do you know that? How do you detect that proactively and be able to raise an alert to an operator so they can take care of that? So these are the key aspects of the solution that we deployed, saving lots of money for this particular school district. This is one example that comes to my mind, Mike.
That's great. Let me pose the same question to VJ.
Absolutely. As we think about, our Johnson Controls ecosystem and how we have so many assets that we are in the process of connecting. You think about asset types, everything from chillers to building automation systems to rooftop units, and the value that Edge AI can bring in terms of rapidly detecting conditions in all of these devices. It's amazing the value that FogHorn is going to bring. One simple example is chiller vibrations. And we're already in the process of working with the FogHorn team around how do we do chiller vibrations in real time? So typically in the past, it takes a technician to go out, collect data on chiller vibrations, which is an early predictor of chiller failure, take it back to a lab, do some analysis, and then determine whether or not, a chiller is in distress. And this process often takes, weeks to perform and only gets performed a couple of times a year. With Edge AI and FogHorn, we're actually able to take the data directly from sensors on the chiller in real time and be able to predict, the outcomes, the potential failure of a chiller in minutes and maybe even seconds, in the not too distant future. And imagine applying that, to every connected asset that is high value and downtime and failure across the enterprise can cause serious disruption. And then really being able to respond to that. And then as we move forward, being able to apply firmware patches, being able to do graceful shutdowns, being able to transition workload over to another smart machine. And you see why this is so critical for us. But we're excited that we've already been able to test and prove that FogHorn is going to add tremendous value in these connected equipment use cases, and that's just the beginning, because as we add multimodal types of connected equipment and being able to correlate and do more Edge AI, we're going to be able to even deliver more sophisticated intelligence at the edge.
What a fantastic story. Thank you, VJ. Johnson Controls has the broadest portfolio of intelligent building solutions in the world, the entire industry. And so such a great story around Edge AI and the outcomes and the value to the building and the owners of the building and the people in the building is pretty impactful and amazing. When you think about the breadth of that portfolio, it's a lot of different solutions in security and fire and HVAC controls and everything else that makes a building really operate. VJ, can you give us a little bit of a view into how might we think about short-term plans and long-term plans for integrating FogHorn into JCI's OpenBlue, as well as with the overall portfolio?
We feel that FogHorn will be part of everything as we connect at the edge. And, our strategy is to really drive much more intelligence across not just the smart buildings, but all of the smart assets that exist within those buildings. And so, this will include putting FogHorn on all of our gateway devices to add additional intelligence on our gateways. It will include, having FogHorn part and leading our OpenBlue Bridge Everywhere strategy around really driving more intelligence right directly into the equipment types themselves, so that, as the equipments connect into the cloud, there's an interrogation layer immediately on the machine itself in order to be able to, streamline the data as well as perform edge intelligence and edge AI. And then as we think about the fully smart autonomous building, and Shastri talked about some of the control that was done in the school district, how do you actually respond in real time and make adjustments directly into the optimization settings of a particular device that's sitting right there on the edge in seconds, so that the owner operators don't have to have costly downtime. So as we think about OpenBlue Bridge, which is our edge, intelligent edge, smart edge, secure edge capability, and integrating FogHorn into that, and really getting that across every piece of equipment, both Johnson Controls and non-Johnson Controls, really aligning to our OpenBlue strategy. We're going to fully equip, the smart autonomous building, and letting it be autonomous at every level of the building, not just at the individual device level, but at the individual plant level, and then across the campus level. And that's really where, you think about these things as building blocks, maybe Lego blocks, if you visualize it and you attach all of them together, and you just truly create, this fully autonomous structure going forward.
So Vijay, one of the things that we hear a lot about is how Johnson Controls is affecting the market, especially around smart, healthy, and sustainable buildings. What does this acquisition really mean in that regard?
This acquisition is absolutely critical to powering the outcomes that create smart, healthy, and sustainable buildings. So if you think about each of these individually, there are literally hundreds of use cases that Edge AI and FogHorn powers into smart building, everything from chiller failure prevention and prediction to being able to cross-correlate signals from smoke detectors as well as cameras in real time to predict specific types of conditions. So it's truly entrenched in everything that happens to create that smart autonomous building. But it's equally important, in our healthy and sustainable vectors. If you think about being able to detect pathogens in a space in real time and being able to increase ventilation in that space, we launched the optimizer, the Healthy Air Optimizer, a couple of months ago, and that is a really valuable asset as part of our overall experiences and outcomes that we can offer building owners. But now we can do that in real time and autonomously leveraging FogHorn. And similarly around sustainability, as you think about a future world where you have battery power, you have weather inputs, you have photovoltaic arrays, and you have current upstream energy sources, you're going to be getting a lot of information at the edge in real time that allows you to make micro adjustments depending upon the outside temperature, as well as the sunlight, as well as your battery capacity in real time, that is going to drive your overall sustainability efforts and help you decarbonize. It's also going to be able to be on different kinds of machine types, applying Edge AI to be able to measure carbon output from those machine types. So you can see that, FogHorn is going to be pervasive across our entire smart, healthy, and sustainable building strategy. and also across all of our key growth vectors, both offered as a digital solution, but also something that we can offer as a service to drive value to help owner operators decarbonize, as well as drive more healthy buildings. And this will also be embedded across all of our products. So FogHorn and this acquisition is fundamentally aligned with all the vectors of growth, as well as our core vision that we presented last year at our Investor Day.
That's great. So in wrapping up, any closing comments? And maybe we'll start with Sastry.
Myself and the entire FogHorn technology team are super excited to be joining Johnson Controls, and by, as I said, combining our technology and integrating with the OpenBlue platform, and not only to leverage across the entire portfolio of all of the solutions that Vijay talked about. I think it's super exciting. Sky is the limit, and this is certainly in line with Johnson Controls' vision for decarbonization, sustainability, and I think Johnson Controls customers would love it, and we're super excited to be part of this journey.
That's great. Let me pose the same question to Vijay.
We're super excited about the FogHorn acquisition, and I would say more than any capability that we've acquired, I think what I'm most excited about are the people that have joined our Johnson Controls technology and engineering team, starting with Shastri, and the entire team that he's built and we've brought over into our ecosystem. Secondly, I'm also extremely excited about the culture of Silicon Valley and innovation that FogHorn is infusing Johnson Controls OpenBlue with. And by bringing in the talent that really has demonstrated being able to innovate in an agile way, I think our organization gets a lot stronger, both culturally and from an innovation quotient. So I just wanted to really, thank Shastri and the team for joining us. I think it's going to be an awesome journey, leveraging what FogHorn has already built as we power into the future here at Johnson Controls.
Great. Thank you very much, Vijay. That was a great explanation. And we have a lot to look forward to in terms of the transformative impact of this acquisition, but also, to your point, how this informs the entire portfolio and how a building actually operates and delivers value. So I want to once again thank you for attending, Vijay and Sastry, and providing us a wonderful chat about this acquisition, what it means to our customers in the marketplace, and what it means in terms of delivering amazing technology to the market to deliver extraordinary outcomes. Thank you very much.